This is an explanation for the Arduino Uno Spaceship Interface project. We're going to start with a video of the completed project in action. You can see here that right now there's power to the system. The green light's on, switch is not depressed. I'm going to start the video now. So now we press the switch. Red LEDs begin blinking. Release, green, press, switches begin blinking. You can see here, it's hard to see here, but by the green it says system ready, by the red it says engage hyperdrive. So now let's take a look at the schematic. So the Arduino Uno, so we have the 5 volts goes through SW1. So the switch is open, there's no power getting to the rest of the circuit. Here we have our ground, this goes through 10K resistor. We have 3 diodes, each wired through a 220 ohm resistor. That's just to modulate down the amount of power coming through. If these resistors weren't here and we were putting this much power directly through, it would blow the LEDs. Then on the right side here, we can see the code for the Arduino, for the Spaceship Interface program. So at the top, we have the comments here. So basically, one green LED, D1 in the schematic, symbolizing system ready, remains lit until the switch, SW1, is depressed, at which point the 2 red LEDs, D2 and D3, alternate, turning on and off every 250 milliseconds, which symbolizes the engaged hyperdrive. This continues while the switch remains depressed. So going into the code, we have here, so int switch state equals 0, so we've initialized the switch state to off. Void setup is where we tell the Arduino kind of what's going on with each of the pins. So on pin 3 is an output, pin 4 is an output, pin 5 is an output, pin 2 is an input. You can see on the comments where they're going to. Essentially all the outputs are the LEDs, D1 through 3, and then the input is going to be SW1, the switch. So now we go to the loop function, which is basically the main function for an Arduino program. So first we're going to get the switch state. So take our variable that we created above. We use the digital read function on pin 2. So we're reading the value on pin 2, which is our input. So high is on, low is off. So if the switch state is low or off, then we write to pin 3 a value of high. In other words, we turn on whatever's at pin 3. So pin 3 is D1 right here, which is our green LED in the video. So now pin 4 is D2 set to low, and pin 5 is D3 also set to low. These are our 2 red LEDs. So again, if the switch is not depressed or the switch state is low, or meaning the switch state is off and the circuit is open, then the green LED is lit and the 2 red LEDs are not lit. So then we have an else statement. So that means that the switch state was not low. There's only 2 values, so it can either be low or high. So switch state is high. Now we're going to pin 3, we're going to turn low. Pin 4, we're going to turn low. Pin 5, we're going to turn high. So D1, the green LED, is turned off. D2, one of the red LEDs is also turned off, or remains off in this case. And pin 5 set to high. So one of the red LEDs is turned on. Then we have a delay, 250. This input is milliseconds, so 250 milliseconds. Then pin 4 is turned on, so D2 is turned on, and D3 set to off. Then there's another delay before it would wrap around in the loop, it would come. So if the switch was still depressed, it would go back into the else statement, and now it would turn off D3. Sorry, it would turn off D2 and then turn on D3. Then wait 250 milliseconds, reverse that, turn on D2, turn off D3, continue on the loop. If it went through the loop After this delay and the switch was released, so now we're back to low, and then green LED would light back up, and 2 red LEDs would remain off. And this continues to cycle until you remove power from the board, basically.